Hey guys, what up? So a friend of mine asked me how Basho.me actually works, so I thought I'd explain it. So how does Basho.me discover haiku hidden in your Twitter feed or in anybody's Twitter feed? So first step, search Twitter. Get the actual tweets we're going to be searching through. So you put in your Twitter name here, obviously. I'm not going to do it now. Instead, I'm just going to scroll down so you can peruse some funny tweets as I discuss this. Probably butcher the explanation, but anyway, that's what it does. It looks for the first 6 pages of results, not all of the results because every additional page takes more time, and that's really the bottleneck here is the communication time with Twitter. But that's enough. I mean, Conan O'Brien has like 220 haiku in the first 6 pages of his Twitter results alone, so that's enough. I mean, you're not going to be wading through that many haiku probably. So then it concatenates all of those tweets into one long string of text. So normally tweets are separated, obviously, but this just strings them all together into one long line of text, basically, so that there's no separation between tweets. I mean, there's like a space between them, but you understand what I'm saying here. There's no real indication that one tweet is different from the next. It's just one long string of words. And the third step is to run the syllable counter on that entire string of words all at once. So you might think that the syllable counter would count the syllables of one word at a time, like, okay, good has 1 syllable, morning has 2, and so forth. Nope, it doesn't do that. It can do that, but it's really designed to run an entire string because that's way faster. It's like 100 times faster at least to do it like that. And the reason it does that is, the reason that's a lot faster is because the way the syllable counter works is that it compares a large number of patterns against that original string that you're searching through, that you're comparing it to or whatever, that you're running it on, I should say. And it's just so much faster to do that on a very long string of words than to do it on each word in sequence. So it just has to do with how the actual pattern matching works, like how it's actually implemented in the programming language. But it's just way more efficient. And there's other reasons for why it works faster like that too. But anyway, that's how it works. And you might be thinking, well, if it counts this, if it is run in this entire long string of words all at once, then how are you getting the individual syllable counts for words? Like, isn't it just returning a number like 60,000 if there's like 60,000 syllables in this entire string of words? And the answer is actually that's not what it does. What it does is it returns not a number, but rather a representation of the initial string, but where the corresponding representation of each word in the initial string is actually a representation of how many syllables that the original word had. So if your string is, I like apples, 3 words, didn't have to count them out for you, but what the corresponding string will be after you run the syllable counter on it is a representation of each of those initial words, I like apples, but it'll be in code, and it will basically encode the number of syllables in each one of those words. So it'll be like hashtags. Hashtag actually represents a syllable. So then you can easily count the number of hashtags in each of these representations and then match them with the original words. And that's basically how it works. It's a little bit more complex than that, but I mean that's the general idea. So yeah, then it matches the original string with the representational string. Then you can figure out that apples has 2 syllables and so forth. And then it actually looks through the through that array of results, and we'll start at the very first word. So now that we know how many syllables are in each word of the entire string, and it'll start at the very first word and then say, okay, I'm going to count out 5 syllables. I like apples very much. Okay, well it actually only counts 5 syllables. So I like apples very. That's not a word. It does not end on a word break after 5 syllables. So obviously haiku has 5 syllables in the first line, 7 in the second, 5 in the third. So we're going to basically count out 5 syllables, see if we end on a word break, which we did not. But if we did, we would then progress to count out 7 syllables. And if we end on a word break on the end of 7 syllables, we then count out another 5 and hopefully end on a word break there so that we'd have the complete haiku. But if we don't have a word break at the end of 5 syllables or of the next 7 or of the next 5 or whatever, we then progress to the next word in the entire string. So rather than starting at I, we would start at like. So like apples very. Okay, that's the start of a haiku. This is not a great example, by the way, but you might sort of understand it now. and then you would count out 7 syllables since we're still continuing. We got the first line. I also like tangerines. So that's 7. So we still potentially have a haiku here, and then whatever else. You get what I'm trying to say here. And yeah, so it just does that, starting at every single word in your entire Twitter string. So you've got this massive thing, maybe, I don't know, 20,000 words or whatever, and it just starts at the starting point and sees if it can count 5, 7, 5, and if it can, it adds that to the haiku, and then it starts at the next word. So you actually can have many overlapping haiku. In practice, it doesn't happen very often. But yeah, that's how it works. Not too complicated, but the way the syllable counter works is, so yeah, it took some figuring to do the syllable counter, because at first it was a little bit slow. It's implemented in Ruby. I actually did implement a version in Java just to see how fast it would be, and it's about 100 times faster. But in Ruby, it's way too slow to do it the naive way of just counting every one word at a time. So that's why I had to implement the kind of weird representational string thing. But yeah, that's basically how it works. And really, the real challenge is just in the syllable counter itself, just in doing all the rules and so forth, because there's so many exceptions. And it's still not perfect. It's maybe 90% accurate for Twitter. Greater accuracy if you're actually comparing it against regular words, but unfortunately Twitter has a dearth of regular words, or an abundance of non-regular words, I should say. So yeah, hopefully that made sense. Probably didn't, but whatever. You probably already, realize how it worked anyway. But anyway, that's it for now. Hope you enjoyed it. Subscribe if you did, and I'll talk to you later.